Hello everyone, my name is Ankit Verma and today we are learning Deterministic Finite Automata, that is called DFA. DFA is finite state machine that accept or reject string based on states. Deterministic Finite Automata. Here the automata is a machine or model. Finite means limited number of states and deterministic, that means it can be determined. So it is a machine which is having the finite number of states and it accept or reject the string based upon the states. In the DFA, if the string is processed and afterward it reached to the final state, in that case it is accepted, otherwise it is rejected. Deterministic finite automata. Here the word finite because the machine contain limited number of states. When we construct the DFA or the machine for some specific language, then there are limited number of states. So in some countable states we can draw that machine. Here the deterministic, that means the machine read one symbol at a time and process it and change the state, and this state can be determined. DFA is just like the game of Ludo, where we roll the dice and we move the next state. And the state define where we are currently, that means it can be determined. In the same way, DFA machine read one symbol at a time and move the state, and that state can be determined. Next thing is DFA not accept null move. That means the states will not change without any input. Null move means epsilon. So in DFA, if we provide the epsilon, in that case, state will not change because state will only change when we provide some input. And epsilon or the null move is not treated as the input in DFA. Next thing is DFA can contain multiple final states. There can be multiple final states in the DFA. The deterministic finite automata or DFA contain 5 elements. The first element is Q, which signify the finite set of states. All the states of the DFA are represented as finite set of states and which are represented by Q. Second element is sigma, which is input alphabet. Alphabet is the finite set of symbols which are given to us, which will be given to the input to DFA. Next element is small q, which is the initial state. This is the start state from where the DFA will start. Next element is F, which is final state. When we provide input to the DFA, and that input reach to the final state, in that case that input string is accepted. Next element is the transition function. When we are on one state of DFA and the input is provided, then we are going to some other state and that is provided by the transition function. So here we have learned the DFA accept and reject the string based upon the states. And in DFA, there are limited number of states. DFA read one symbol at a time and based upon that, it change the state and these states can be determined. That's why the name given is deterministic. And the finite number of state gives finite and machine gives the name automata. That's why deterministic finite automata means DFA. Next thing is DFA not accept the null move means epsilon is not taken by DFA. If we provide the epsilon, DFA state will not move. The state will move only when the input is provided. And DFA can have multiple final states. DFA contain the 5 elements. The first is finite set of states, then input alphabet, then initial state, final state, and the transition function. To understand more, we are taking one example and will construct the corresponding DFA. So here we are taking one example. Construct DFA means we are going to construct the deterministic finite automata which accept set of all string. So we are going to accept the all strings over sigma equal to a comma b. So this is the input alphabet. So here input alphabet given is the sigma equal to a comma b. Here sigma is alphabet, a and b are the symbols. Alphabet is the set of symbols. So from a comma b we can create various strings and these strings should start with a. So here we are going to construct a DFA for all the strings which start with a. Now we are going to construct the language. So we are taking L, which is a language that is equal to, it will contain all the string which start with A, and that can be formed using A and B. Just like we are having single A, 2 times A, or 3 times A, 4 times A, 5 times A, or we may have AB, then ABB or ABA and so on. So this is the infinite language where each string start with A. For this language we are going to construct the DFA. For constructing the DFA we must be having the initial state which is called the start state from where the DFA will start accepting the string. And the initial state or the start state is represented by a circle which is having the incoming arrow. So let us suppose that we are creating the DFA where we are having the initial or the start state with the incoming arrow. Let us assume I am giving the name of that state is Q naught. This is the initial state from where the DFA will start. To construct the DFA, the shortcut formula is we has to see which is the minimum length string. So here in the complete language, the minimum length string is A. So we has to work on this A, then complete DFA will be designed. So here we are on the initial state and let us suppose that A will come. We know that DFA change its state just like the Ludo game. For every move it changes the state. So whenever we are having some input the state will change. So from Q0 we are going to change the state to some other state. Now here we are going to draw another state, but important thing to note that this A is accepted by the DFA, which means it will be the final state. Final state is a state where the string is accepted and that is represented by the double circle. So as single A is accepted by the DFA, that's why I am providing the double circle. So this is the final state. And let us suppose that the name of this state I am giving is Q1. Till here we have learned that to construct a DFA, first of all find out the minimum length string in the language. And for that, we are going to construct the DFA. The DFA will start with the initial state. Let's say it is Q0. Then afterward, take that minimum length string. Then for every symbol, there will be change in state. So here, the A is accepted. That's why we have taken is the final state, which is represented by the double circle. Now we are going to the next level. Let us suppose that 2 times A will come. So here, for the first A, we will start with the initial state. Then this first A will go to the next state, and again one more time A will come. So we has to accept this string. That means whenever we are on the Q1 and A comes again, so from this Q1 we are coming back to the Q1 because this is the final state. So here for first A we will move from Q0 to Q1, and for second A we are coming back to the Q1. That means we are on the final state and this will be accepted. What will happen if 3 times A will come with that machine? So for first A, we will move from Q0 to Q1. For second A, we will again go back to Q1. For third A, again go back to Q1. So this is the infinite loop, means multiple times A will come, we are keep on accepting. So 3A, 4A, 5A, we are keep on accepting. Now we are going to modify this DFA for the next input. Let us suppose that AB will come. So for first A, we are going to move from Q0 to Q1. And for this B, again we are going to accept. That's why I am putting the A comma B. Means any of the thing will come, we are keep on accepting. So understand, for AB, for first A, we will move from Q0 to Q1, and for B, we are coming back to Q1, which is final state, and this string is accepted. Now let us suppose that we are having ABB. Now for A, we will move from Q0 to Q1, then for B, it is self loop, coming back to Q1, again for next B, again it is coming back to Q1, which is the final state, and this is accepted. In the similar manner, if we have the A, then Q0 to Q1, for the B coming back, again for the A coming back. So this is accepted. So all the string which are starting with A will be accepted by this DFA. But this DFA is not complete. In the DFA, important thing to note that on every state, we have to address all the input alphabet. And here we have given the input alphabet which are A and B. On the state Q1, we have addressed A and B, means if A will come, we will come back. If B will come, we will come back. But on the state Q0, we have addressed only A, means if A will come, we will go to the Q1. But what will happen if on Q0, B will come? We have to address that also in the DFA. Now let us assume that somebody has entered B or 2 times B or 3 times B, 4 times B, or BA or BBA, and so on. So these are the string which are not starting with A, means this DFA should not accept all these string. For these string, we are going to generate a dead state where DFA will not accept these string. So out of these string, we are picking the minimum length string, which is the B. So in the initial state Q0, whenever the B will come, then we are going to the another state. Let us suppose the name given to this state is Q2. This is the dead state, because from this state we cannot move further, and this is not even a final state. So here the DFA will hold and string will not be accepted. So this B is not accepted by this DFA. Let us suppose that 2 times B will come. So we are going to modify this DFA. For the first B, we are going to move from Q0 to Q2, and for the next B, we are having a self loop. Self loop means we are coming back to the same state again. So when the B will come, it will come back to the same state, which is a dead state. So B and B, again we are on the dead state, so this will not be accepted. If we are having BA, in that case, what will happen? We are going to modify this machine. So here for the first B, we are having Q dot to Q2, and for A, now I am putting the A also. So for A, again it will come back to the dead state. So this string will not be accepted. Next string is BBA. So for the first B, from initial Q0 to Q2 we will come. For B, we will again come back, and for A, again we will come back. So this is the dead state. This will also not be accepted. So this DFA is now constructed. Here we can see that on every state we have addressed A and B, which are the input symbol. Means on Q0, if A will come, we will go to Q1, and if B will come, we will go to Q2. And on Q1, if A or B will come, we will come back to Q1, and Q2, if A and B will come, we will come back to Q2. So this DFA is now complete. It will accept all the string which start with A and reject all the remaining string. Now we are understanding the 5 elements of DFA. The first element we have learned, which is input alphabet, which is given to us. That is the set of symbol which is A and B. Second thing is the initial state, which is represented by the Q. So Q is equal to, here in the DFA we are having the start state, which is Q0. So here in the set we are representing Q0. This is the initial state, which is represented by the circle with the incoming arrow. The next element is the final state. Final state is the state where the string will be accepted, and it is represented by the double circle. So here in the DFA we are having Q1. This is the final state. So here I am representing F is equal to the set of final state, and the final state is only Q1. So inside the set I am putting the Q1. Next element of DFA is Q, which is finite set of states. So all the states which are present in the DFA, these all state will come in Q. So here Q0, this is the first state, comma Q1, this is the second state, comma Q2, this is the third state. So this is the finite set of state, means all the states of DFA are represented as Q. And initial state and final state, these are the subparts or subsets of finite set of states. So we can say that small q, that means the initial state, is the subset of capital Q, which is set of all states. Also capital F, which means final state, is also the subset of set of all state, which is capital Q. Next element is transition function, and transition function is represented by Q cross sigma, and that provide the Q. Now let's understand. This Q means set of all states. So here I am taking set of all states, which is Q0, Q1 and Q2, and cross with the sigma, and we know that sigma is A comma B, and that will give us again Q. That means again it is Q0, Q1 and Q2. So if I multiply these two, here I will get Q0 comma A. So here Q0 with A I have multiplied, then Q0 with B. So Q0 comma B. In the similar manner, Q1 with A. So Q1 comma A and Q1 comma B. In the similar manner, Q2 with A. So Q2 comma A and Q2 comma B. And here on the right hand side we are having Q0, Q1 and Q2. So here I am representing Q0, Q1 and Q2. The transition function tells the state, means let us suppose we are on Q0. So we are here on Q0 and A will come. So what will happen? We will go on Q1. So from here we will go on the Q1. Secondly, if we are on Q0 and B will come, so in that case we will go on the Q2. So from here we will go on the Q2. Third is, if we are on Q1 and A will come, so what will happen? So from Q1 A is coming and we are coming back on the Q1. So here we are putting the arrow till Q1. Next is, we are on Q1 and B will come. So here we are coming back on the Q1. So here we are putting the arrow till Q1. Next is, we are on Q2. So here the state is Q2 and A will come. So for the A, self loop means we are coming back on Q2. So here putting the arrow till Q2. Next we are on Q2, so this is the state Q2 and B will come. So for the B again we are coming back to the Q2. So here we are marking till Q2. So the transition function says that we are on some state and some input symbol will come and we are going to some other state. This is the transition which is given by the transition function. We can also draw a table for the transition function. So this is the transition table for the transition function, where we are having the three fields. The first field signify the present state, and second one is the next state if A will come, or the next state if B will come. So we are starting with the first state, which is Q0. So here in the present state I am marking Q0. We know that Q0 is the initial state or the start state. So whenever we are mentioning the start state, we will mention this arrow. This signified as the initial state. We are on the Q0 and A will come. So we will come to the Q1. Or from the Q0, if B will come, then we will come to the Q2. Now we are taking the another state, which is Q1. This Q1 is the final state. That's why I am putting this star. This star signifies it is the final state. On Q1, if A will come, so here we are coming back to the Q1. And on this Q1, if B will come, in that case again we are coming back to the Q1. Now we are taking the next state, which is Q2. On this Q2, if A will come, then we are coming back to the Q2. Or on the Q2, if B will come, again we are coming back to the Q2. So this is the transition table for the transition function. So here we have designed the deterministic finite automata or the DFA for the string which start with A, and we have also designed its transition table. So that's all for today. Thank you.